Hello, my name's Marcus, and this is my video where I show you how I verified proper function of the vacuum secondaries on my Holley 4160 carburetor, and then how I transitioned into tuning the right spring for the vacuum secondary diaphragm itself. I've got a 1968 Chevy Camaro. It's got a 396 in it. As I said, it's a Holley 4160 vacuum secondary carb. Got a Muncie M21 close ratio transmission and 373 posi gearing in the rear end. If you've ever worked on one of these carburetors, you know that the vacuum secondary looks like this. It draws vacuum through this port with the red arrow, which draws the rod upwards in the diaphragm. In the primary bores, there is a medium-sized Venturi port that draws vacuum into the diaphragm assembly upon load. There's also a smaller Venturi port on the secondary side of the carburetor. This comes together with the vacuum from the primary ports and draws on this port on the outside of the carburetor. I removed the plug where the green arrow is so I could fully clean out these ports. It's really important that this area is cleaned well, and then I retapped it and put a screw in there to reseal it. I got a quick change kit for the springs and a full range of spring tensions. You can see they range from the black spring to the white spring, and my original is shown. It's a little bit taller than the normal plain one. There's a number of great videos already on YouTube. One person used a wire tie around their diaphragm to make sure it works. It's very common for people to recommend putting a paper clip on there as well, and to make sure that it moves after you've driven it. And there's also a nice video where they have video recording under the hood showing improper and proper vacuum secondary function. Well, I wanted to add a tachometer to my video so I could see at what engine speeds the diaphragm was initiating and then fully open. And I had 5 different ones, including my timing light. And then I wired them all at the same time to my engine so that I could determine which ones were accurate and responsive. Here is the test underway, and a couple of these are just cheap eBay tachometers, in particular number 1 and number 3. Tachometer 2 and tachometer 4 were very accurate. And tachometer 5 was accurate as well, but it was slow. I built this setup. I took a piece of aluminum and I put a bore scope on it, and so that I could have a light under the hood, and then I aimed that bore scope towards the vacuum secondary rod underneath the hood. I then ran that into the interior of the car where I could turn the recording feature on and off and see what was happening. Here's an example of my version 1 of this apparatus. There's no tachometer, there's no sound, but I was able to see that my vacuum secondaries were not opening all the way. The spring that I had in there was simply too stout to generate enough vacuum to overcome. So my version 2, I added a digital tachometer to the assembly, and here's an example of that running. It's the same thing, but now I can see engine speeds with this digital tachometer on the left. And I'd also done a little bit of other work so that now with that same spring it was opening all the way. Here's my version 3, the final one, where I made 2 changes. I added my GoPro to it to get better resolution and sound, and I also switched over from the digital tack to the analog tack with a needle on it. So here's the whole assembly. I powered the GoPro and the borescope from USB power so they wouldn't die out. And I powered the tachometer from my electric choke, and you need a small air cleaner. Here's my 4-gear test with my spring. Now here's a 3rd-gear roll-on, which is a little slower, and it gives you more accurate understanding of RPM. I did a bunch of testing, but ultimately ended up on the white one. So here I am, pulled over on the side of the road and swapping out the white spring back for my original plain spring for the purposes of this video. And I like to make it easy to remember things, so my label printer made it easy to document whether it was the white spring, the original, or any of the others that I did. But I got pretty good at changing these quickly. Here's a 4-gear test with the white spring. So from these tests, I determined that my car could operate with the white spring, the lightest spring, and have the most responsive opening of the 4-barrel. I did like having both the GoPro and the borescope connected at the same time. That worked quite well. And I took the time to put some good connecting ends on the power, the ground, the coil tachometer signal wires, and so on, to make it easy to connect to the engine. The aluminum bar simply bolted down to the back stud of the carburetor, and it held quite still. And looking back again, here are the parts that I used. You're going to have to probably put a small air cleaner on. I bought a cheap one at the auto parts store to give me enough room. And I would recommend that you run all your devices off of USB power so you don't run the risk of running out of battery power in the middle of your setup. I hope this video was helpful, and if anyone has improvements on this design, I'd love to hear from you. I hope this is enjoyable and it's helpful to any of those of you out there that have a Holley car.